Hey Zipporah, this has been a long time overdue, this video, so I want to thank you for being patient with me. The last time we were together, we talked about the quadratic formula, and there's a part of me that kind of wants to go over it again because it's been so long since we've seen each other, but I know it's going to eat up a lot of time in the video and it won't give us what we need. So check it out. The quadratic formula is when we took the general form of a quadratic equation, ax squared plus bx plus c equals 0. And then what we applied to it was the completing the square, right? Which is a process for solving quadratic equations that you got really good at. So we completed the square, and after that we found out that x was equal to nope, that's incorrect. X is equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. We have this cool little rule that we can use every time, because mathematicians often will take a generic thing, a general thing, and apply a specific thing to it to get another general thing. What this is basically doing is solving for x. And so what we did is we solved for x in a generic way so that we can apply this formula all the time. So this reminds me of literal equations when we were dealing with those, like solving for a variable in an equation. Anyway, this is the quadratic formula. It's a big deal. It is worth memorizing. So that's our first vocabulary word, quadratic formula, which we know to be this. And the next word is a discriminant, and this has a really interesting application. The discriminant of a quadratic equation really is a part of the quadratic formula. So if I were to take, if I were to highlight just this area here, let me use orange. If I were to highlight this, b squared minus 4ac, this is considered the discriminant. So I'm going to highlight the word discriminant too in the same color so we know that these guys are related. So the discriminant is a part of the quadratic formula. The beauty of the discriminant, though, is that this little formula, b squared minus 4ac, that part of the quadratic formula gives us so much insight into the types of answers we get from our quadratic equation. Let's keep going and let's see how this works out, because I think some of the slides that I have up here are going to explain it a little bit better. So here in our first example, we've got two rational roots. Let's just remember what rational means. Rational numbers are numbers that can be written as fractions, specifically as a ratio of integers. So if I can write a number as some numerator over some denominator, then that number is considered a rational number. Numbers that are irrational, that are not in that category, are like square root of 2, pi, some number e we haven't talked about yet. So these guys cannot be written as a fraction, and in fact, if you write them as a decimal, they go on and on and on, repeating, and we're not repeating at all, sorry about that, and going on and on in unpredictable ways, in a sense, all right? Maybe that's not the right word, but the idea is that the decimal version of an irrational number goes on and on. The decimal version of a rational number goes on and on repeating, or it terminates, it stops. And we've talked about that before, so I won't get into it again. All right, so we're going to solve this guy by using the quadratic formula. The first little hint we have here is the first thing we should write the equation in this form and then identify a, b, and c. So we'll do that. So we have x squared minus 12x equals 28. And if we put it in the correct form, this 28 comes over. In a sense, I'm subtracting 28 on both sides. And what I end up with is x squared minus 12x minus 28 is equal to 0. So now that I have it in this form, I'm going to say that this is an ax squared plus bx plus c equals 0 form. And here I can see a is equal to 1, right? B is equal to negative 12, and c is equal to negative 28. And to solve this, basically, I'm just going to literally, matter of fact, I'm going to literally go back up here and grab the quadratic formula. And when I grab it, I'm going to copy it here and paste it right back down here. And with some color coding, I can see where I'm going to place what in order to do my solution, or in order to find my solution. So negative the opposite of b, or negative b, means the opposite of whatever b is. Since b is a negative 12, I'm going to put a positive 12 plus or minus b squared. Negative 12 times negative 12 is 144. Minus 4 times a, in this case, is 1 times c, which is negative 28. All of that is over 2 times a, which is 1. And now this is really just an exercise in simplifying a mathematical expression. And so what I like to do is I like to deal with what we're going to later talk about as the discriminant, what's going on underneath the radical first. So x is equal to 12 plus or minus the square root of 144 minus 4 times 1 times a negative 12. We're going to end up adding this because this is going to be a negative times a negative. So it's going to be 144 plus 112, all of that over 2. And now when I simplify this under the radical, I end up with 144 plus 112 is going to give me a 256, which is a perfect square. It's 16 times 16, I believe. And then so we have that over 2, x is equal to, so here's where we're getting our two answers from. Let me not get ahead of myself. So x is equal to, so this is 12 plus or minus 16 over 2. And these are two rational answers, meaning two real number rational answers, numbers that I can write as fractions. 12 plus 16 is going to give me, I'm doing the plus one first, it's going to give me 28 over 2. And 12 minus 16 is going to give me a negative 4 over 2. So my two possible answers are 14 and negative 2. So I will write that as x is equal to the solution set of maybe negative 12. No, that's not negative 12. I was trying to write the negative 2 first. Negative 2, pardon me, and then 14. So pretty much that's what we want to do for whenever we're using the quadratic formula. And over here I have a quick little example for you, or an opportunity for you to try it yourself. So you see here it says solve x squared minus 8x equals 33 by using the quadratic formula. Think about the process that we did. I'm going to give it like a couple second beat, and so you should pause it now because I'm going to put the answer up soon. So definitely try this. All right, so x is equal to negative 3 and 11. Let's try the next example. Okay, so this next example 2, talks about one rational root. So sometimes we can get an answer to our quadratic equation where there's only one answer and it's one rational root. And let's see the circumstance. So we're going to solve this by using the quadratic formula. So I rewrote the quadratic formula, which I think is a great practice, and the best way to kind of memorize is just to write it over and over again whenever you're doing your problems. I rewrote this down here and notice that everything lined up really beautifully, so that I don't really have to do much more than say that A is equal to 1, B is equal to 22, and C is equal to 121. I'm going to plug it in. So we're color-coded and ready to go. X is equal to the opposite of B, which is negative 22 plus or minus the square root of 22 squared. I don't know that offhand, so I need to do that one. Times 4 times A, which is 1, times C, which is 121. All of that over 2 times 1, which is A. So then I found out that 22 squared is 484, and then 4 times 1 times 121 is 484. If you take a look at what we're later going to refer to as the discriminant, right underneath the radical, this is going to be 0. So it kind of makes sense that here we only have one answer. X is equal to negative 22 plus or minus 0 over 2, which is really just negative 11. The answer is negative 11. So x is equal to the set that includes just negative 11. Let's give you an opportunity to practice. All right, so here we are with example 2b. Solve this guy, x squared minus 34x plus 289 equals 0 by using the quadratic formula. Pause me now, the answer's coming up. So we get the single rational answer of x equals 17. Let's take a look at example 3. So sometimes our answers can be irrational roots, numbers that don't work out nicely. And we talked about irrationals last time being numbers that are going to sometimes be radicals, or numbers that whose decimals are neither terminating nor repeating. So let's get started. So by now you've practiced and seen this enough, you know the drill. We're just going to plug everything in. This was already lined up nicely, so we were able to simply do what we need to do. So I'm going to just substitute in my A, B, and C. So here we see that A is not 1 like it has been, so now we have a little bit more work to do, but not hard at all. We'll continue working through this, right? Multiply 4 times 2 times negative 5. We end up with a plus 40. Add it together. We get a positive 56. Already you know this isn't a perfect square, so we're going to be adding some kind of radical and subtracting a radical. Let's see if we could simplify this. We remember when we simplify radicals, we need to figure out what numbers multiply to make up the number underneath the radical. And we know 4 and 14 make up 56, and therefore we can take the square root of 4 and simplify this even further. So now we get negative 4 plus or minus 2 root 14 over 4. This looks good. Now we've got to simplify this even further, and I'll do that over here by rewriting, then breaking my fraction up in 2. And I get something like this, negative 1 plus or minus the square root of 14 over 2. If you needed to find the numerical answer to this, you would honestly just pop it in the calculator, and you would find that x is equal to approximately negative 2.9, and the other answer is that x could also be equal to 0.9. And we can see that by doing negative 1 plus the square root of 14 over 2, and then doing it the other way, negative 1 minus the square root of 14 over 2. So these are our answers. Let's give you a chance to try. All right, so let's try to solve this guy by using the quadratic formula. And this one, we're going to have a situation similar to what we had before, which is we're going to have an irrational ending, an irrational root. And remember, problems like this that have irrational answers, you can't factor. Like the other ones that have rational answers, you can factor, but irrational answers we can't. So pause me now, try it out, and I'll give you the answer. All right, so x is equal to plus or minus the square root of 7, and that's approximately, that's what these wavy lines mean, that's approximately 0.4 and 5.6. Let's go ahead and try example 4. So here in example 4, we have something called complex roots. We remember complex numbers. Let me get this out of the way. We remember that complex numbers are numbers of the form a plus bi, so that means it's got that imaginary part that might come up. So that's what we're going to have with these types of problems. So we're going to do all the same stuff. Using the quadratic formula, here's what we do. I grab my good friend, the quadratic formula. I move this 13 over to the other side so that it's in the correct form. I figure out what A, B, and C are. Now I'm going to plug them in. When I plug in this minus 4, the opposite of minus 4 is plus 4. So I have 4 plus or minus all of this stuff here, which we're going to soon talk about as a discriminant. And we're going to simplify underneath the radical. When I do that, x is equal to 4 plus or minus the square root of 4 times 1 times 13 is going to give me a larger number than this 16. So I'm going to end up doing 16 minus 52. That's going to give me a negative under the radical, and that's where I'm going to get my irrational answer from. Not irrational, I'm sorry, my imaginary complex root from. So 4 plus or minus the square root of negative 36 over 2. When I have a negative under the radical, I got to pop out the I. So I get this square root of 36 is 6. So instead I get 6i over here. And then I'm going to divide each of these by 2. So I get that x is equal to 2 plus or minus 3i. And those 2 plus 3i and 2 minus 3i are my two values or answers that I've gotten for x, both of them complex and imaginary. So this would be a situation if we were to graph the corresponding quadratic where our parabola would not actually intersect the x-axis. Let's give you a chance to try. So solve this guy right here by using the quadratic formula. Pause me now. I'm about to give you the answer. So your answer is 3 plus or minus 2i. Also, take a note that 6x was on this side and you needed to bring it over, and this is the b term. I don't know if that may have caused any confusion, but sometimes the problem can look like this. Let's go ahead and take a look at some of these key concepts here. So the idea of the discriminant, which we talked about earlier, is that it is the part of the quadratic formula that's underneath the radical. It is b squared minus 4ac, and depending on its value, we can determine what type of answers or roots we'll get to our problem. So I'm going to actually start the next video discussing this. So tune in for that one. I'll talk to you soon, sweetie.